Hello everyone, welcome back. In today's video, we are going to talk about transformations and actions in Spark. Transformations and actions are the one of the most frequently asked interview questions in Apache Spark. In the previous videos in this playlist, we talked about Spark evolution, history, ecosystem, RDD, data frame, and dataset. If you have not watched any of these videos and if you are interested in watching them, I'll share the link to the playlist in the description of this video. Now we are going to deep dive into transformations and actions in Spark. Basically, the lowest level of abstraction in Spark is RDD, as we know already. And on top of RDDs, we can perform two types of operations. They are transformations and actions. Transformations are lazily evaluated in Spark, meaning they don't execute when they are called. Instead, Spark will remember the series of transformations that we are applying on top of the data, and whenever it encounters an action, the entire series of transformations along with the action will get executed. And this series of transformations that are remembered by Spark are called DAG, Directed Acyclic Graph. Basically, in Spark, we do many operations like map, filter, some aggregations on top of the data. All of these are transformations in Spark. The operations such as printing the data or collecting the data or saving the data, these kinds of operations are called actions in Spark. And the difference between transformations and actions is that for transformations like map, filter, and any aggregation, once these are applied, we don't know what to do with the data. In the sense, Spark doesn't know what to do with the data. It has to store this data in memory. It has to spend lot of compute resources for performing this transformation. And if let's say that you have a data frame or an RDD and you are applying some transformation on top of the data, and the end, if you are not using the result data frames or the result RDDs, and the memory and storage space that is spent for these transformations will go on waste. Let's say that you are applying some transformations in Spark and then you are calling an action. When you call an action, let's say if you are printing or collecting the data needs to be displayed, right? You need to see the data. For displaying the data, Spark need to execute the entire steps. So this is the end use of the data. It might be displaying the data or saving the data. We know the end use here. Only when we know the end use, Spark will execute. But in case of transformations, you apply a map, but where the resultant data is going, it's not going anywhere. You are not at least seeing what's happening with the data and you are not storing anywhere. So nothing is going to happen with the data. And all the operations that comes under this category are called transformations in Spark. And the process where Spark remembers the sequence of transformations that are applied and the transformations get executed once an action is called, this process is called lazy evaluation in Spark. To understand these transformations and actions in Spark better, let's see an example of word count problem, which we have already seen in the previous videos. With the word count problem, we are basically reading a file and then performing flat map. On top of that, we are performing map and then we are doing reduce by key operation. So with all of these files, right, we read the data, but the end use is not defined. We just read the data, but there is no end use defined. So as soon as this line is executed, Spark will remember this step. So this is the transformation one step. And then when this line is executed, Spark will remember one more step and it will create a lineage that step 2 has to be executed after step 1, right? And again, when the map line is seen, Spark will create one more task or step and it will remember this lineage. And then on top of that, we are performing reduce and Spark will again remember the step 4 and it will create this tag. So this is called tag in Spark, as we already discussed. Now we are doing collect on top of this data. What collect does is it will bring all the data, all the data from input RDD into driver, and we can see that data. So collect is actually an action in Spark. So as soon as collect is seen by Spark, we are applying collect on top of the input RDD, and input RDD has all the steps involved. So Spark now create one more task, which is task 5, and this task 5 is an action. So Spark has seen an action here, and it will execute all the steps that are needed to achieve this action, to do the collect, because without executing the above steps we cannot collect the data. Let us try to implement this same in our Spark shell and see what is happening in the Spark UI. I'm starting a Spark shell, and Spark UI is available here. We have our Spark UI here, and there are no stages, there are no jobs. What we are going to do is we are going to read a file that is present in my machine and then execute these steps one by one and see what is happening in the Spark UI. So let's execute these steps one by one. What I'll do is I'll just read the text file into input RTD, and I use sc.text file method to read the file, and my file is located at desktop, and the file name is temp.txt. So as we have executed one step in the Spark shell, and this is a transformation like we have discussed here. So when a transformation is ran, Spark should not ideally execute anything in the backend. It should just store the sequence of steps, right? So let us see in the UI if this is true. And we can see that there are no jobs, there are no stages, and nothing got executed in Spark. So likewise, whenever a transformation is executed and whatever might be the transformation, nothing will get executed by Spark. And Spark in the backend, it knows that this input RDD is a text file that we have read using Spark context dot text file method. Now I will create one more RDD called flat mapped RDD, and this flat mapped RDD is applied on top of this input RDD. So we have this input RDD, then we perform flat map, and with flat map we just take every line and split line into words. Then see, now I am performing a flat map, right? So the flat map is done, and let us see if Spark has executed anything in the backend. I'll just go to stages, nothing, jobs, nothing. You can see that nothing is getting executed in the backend because these are transformations. Now I'll do one more thing. I'll run map as well. Map RDD. Map RDD will be applied on top of the flat map RDD. We take each and every word and assign one as count for every word. Now this is done, and even now Spark has not done anything in the backend. And finally, let me apply this reduce by key as well. I'll call it reduced RDD. It's applied on top of map RDD. So the reduce by key is also done, and nothing got executed in the backend. And now finally we applied everything till here, and now let's do this collect, and collect is done on top of the reduced RDD. I execute reduce RDD dot collect and see what happens. So I executed an action. So till now it is displaying the type of the variable, and now when we perform collect, it has to actually display the real data for us, real data on top of which all these transformations and everything is applied. So when we called collect, what Spark will do is it will look for this reduced RDD, and reduced RDD is here. This reduced RDD needs map RDD, and it will again go back to map RDD, and it will look for flat map RDD, and it will again go back to flat map RDD, and again it will look for input RDD to apply flat map, right? And this input RDD is basically reading this text file. So all these steps in sequence will be executed by Spark. We can see that in UI now. See, when we go for jobs, this collect is executed, right? We click on collect. It is showing two stages. One is reading the text file, then applied a flat map, then applied a map, then applied a reduce by key. On top of that, we have collect operation. So this is how Spark is a lazy evaluation engine, and all the transformations in Spark are lazily evaluated. Now, if you observe one thing, all of these are transformations. Reading a text file, flat map, map, and reduce by key, everything is a transformation. But the difference that we see here is the first three transformations are present in stage 0 and reduced by key is present in stage 1. The reason for that is reading a text file, flat map and map are narrow transformations and reduced by key is a wide transformations. Even in transformations we have two type of transformations. One is narrow transformations and one is wide transformations. Whenever there is a switch from wide to narrow or narrow to wide transformations, the stage will be modified. So these are narrow transformations and this is a wide transformation. So it will be a separate stage. After this reduced by key, if there are any other narrow transformations, again the stage will be changed. It will go to stage 2. So that is how transformations will work in Spark. And to understand the narrow transformations and wide transformations better, we know that Spark is a distributed computing engine. Let's say that we have 4 nodes in Spark and data is split into 4 parts. Let's say that we have part 1, part 2, part 3 and part 4 here. Data is distributed. And when we applied map or flat map, map will be applied on this data and written into some other node. And again, it happens same for the data present in other nodes as well. So in this case, data from node 1 is read and written into one node. It's like 1 to 1 mapping. So one node to one node. And when we applied flat map, same thing would have happened. Like it reads the data and it will write into a other node. At the end, when we did this reduce by key, let's say that we have word W and one here and word T and one here, right? This is the result that we have till now, and reduced by key will be operating on top of this data. Let's say that we have word and one here and T and one here and H and one, I and one. Let's say that these are words, not letters. I'm just simplifying it. A, 1, H, 1. So now when we did this reduce by key, we need to look for all the W comma ones, all the W comma ones and aggregate them. So we need to shuffle the data. Whenever there is a shuffle operation required for any transformation, those transformations are called wide transformations. And if there is no shuffle required, like if we have one-on-one mapping like this, these are called narrow transformations. So all the wide transformations will depend on data from multiple partitions and the data will be shuffled. And some examples would be group by key, reduce by key, join, sort by key, co-group, etc. All this comes under wide transformations. And the operations such as map, filter will come under narrow transformations. And finally, here are few examples for transformations, actions, from narrow transformations and wide transformations. So the operations like map, filter, flat map, map partitions with index are narrow transformations, and group by key, reduce by key, join, sort by key, and co-group are wide transformations. The operations which involve actually printing or saving the data are actions. So they are collect, count, take, reduce, save as text file, for each. For each is also a action because for each to work, it should know how many input values it has in that list. It should actually know the values in the list. So it is an action. This is all about transformations and actions in Spark. If you find this video useful, share it with your friends and hit on the like button. Thank you for watching.